Somewhere along your journey into professional musicianhood, a helpful music educator probably gave you some sort of acronym. Maybe it was FACE, or Every Good Boy Does Fine, or my personal favorite, Good Burritos Don't Fall Apart. There's no shortage of beginning music methods or curriculums out there, but for those of us who now find ourselves molding the young minds of music students, there does seem to be a gaping hole in our music education, for which I offer the following acronym. Musicians need to learn basic biology. But before I tell you what it stands for, let's get a couple of facts out of the way. First, a 1987 study by the International Conference of Symphony and Orchestra Musicians found that 76% of their members had experienced a playing injury that seriously affected their performance. Skip forward to 2012, a study done in Australia which surveyed the musicians in the 8 full-time symphony orchestras found that 84% of participants had experienced pain or injuries that had interfered with playing their instruments or participating in normal orchestral rehearsals and performances. If you missed it, 84% is 8% higher than the first study. We're actually increasing our rates of injuries. And so, once again, I offer the helpful acronym, musicians need to learn basic biology, or muscles, nerves, tendons, ligaments, bones, and blood. The basic things going on inside of us that have been pushed out of our memories from high school biology class to make room for Bach preludes. So let's find out why these basics that make us whole people should be as important to us as a whole note. First, muscles. Muscles are the things that move us. Literally. Like, I'm not talking about the first time you heard Mahler Symphony No. 2 and were so moved, but like they actually move us. Muscles work through contraction and relaxation, so while they can pull us into a new shape, they can't actually push us back. They can only relax us back. So for this reason, they work in a buddy system, with a flexor and an extensor. When you prepare to play an instrument, your elbow bends. It pulls your forearm up. This causes the bicep muscle to flex. As long as your elbow is bent or pulling, your bicep is in flexion. When you're done playing, your tricep muscle extends or pulls to straighten your arm back out so that the bicep can relax. But problems can happen when the arm is flexed or bent for too long. When it's pulled for too long, it overworks the flexor and underworks the extensor. Now, the bicep is strong, but the tricep is weak. Muscles in constant flexion have to be stretched back out, otherwise life gets unbalanced between the two buddies. Muscles like the bicep and the tricep are skeletal muscles. They are controllable, they are growable, but they also are tired-outable. But the good news is muscles like our intestines or our heart are smooth muscles or involuntary muscles, and they keep us going no matter what. Number 2, nerves. Our muscles wouldn't get very far without our nerves. In fact, they wouldn't get anywhere. That's because our muscles rely on coordinated signals from the brain to tell our body what to do. Involuntary muscle movements are buried deep in our brainstem, near the connection to the spinal cord, while our voluntary muscles have connections in the cerebellum and motor cortex. The motor cortex, located higher on the brain, sends out a signal telling a muscle to move, and the cerebellum then coordinates the muscle movements being signaled. The signal travels down the spinal cord to the peripheral nerves and tells them to move the muscles. The peripheral nerves translate signals back to the cerebellum to tell it where the muscle currently is and what it's doing. The resulting communication repeats multiple times, resulting in smooth movements. This brain-to-muscle communication is happening via our nerves constantly and insanely quickly, but it can be easily interrupted. A pinched nerve can cause pain, weakness, tingling, numbness, limited muscle usage, and a pinched nerve may result from something as simple as a swollen muscle or pressure from nearby bones. A pinched nerve in the spinal column may result in poor communication to any one of our muscles. You might finally be getting some little throwbacks to high school bio now with all this talk of muscles and nerves, but there are a couple of players who are often overlooked or completely forgotten about. And those guys are tendons and ligaments. Tendons are slightly flexible cords made of collagen tissue that connect muscles to bones. Ligaments are tougher, shorter cords of connective tissue which connect bone to bone, such as a joint. Tendons are important because they let the structure of our body move, while ligaments are important because they stabilize our joints. Tendons, however, are often damaged through repetitive use. While a muscle may strengthen, the flexible collagen tissue, aka the tendon, may actually weaken. These micro tears that we put into our tendons from overuse can over time turn into macro tears, and that dreaded word to every musician, tendinitis. The good news for ligaments is that they aren't often damaged. In fact, it usually takes a heavy blow or a trauma, such as a fall, on the joint improperly to result in any sort of damage to ligaments. Alright, we've arrived at the biggest and perhaps the most obvious one, which is our bones. Our muscles, nerves, tendons, and ligaments would be nothing more than a blob on a floor if it wasn't for our bones. And they're pretty cool because they're both lightweight enough for us to move, but also strong enough to hold us and support us. Combination of proteins, collagen, and calcium phosphate, bones are made up of two types of tissues. The compact bones, which is the strong and hard outer part of the bone, and the cancellous bone, the soft, spongy looking inside where bone marrow is found. One thing to note is that broken bones are actually just really large fractures. While smaller fractures may take less healing time, any significant fracture is going to be enough to cause pain whenever you try to move or put pressure on it. However, unless you have some sort of bone disorder, it takes a lot of force to fracture a bone, and the likelihood that your music practice will be the cause of it is pretty much slim to none. However, everyone does begin to lose bone mass after age 40, which makes the body more susceptible to injuries. So please avoid dropping a timpani on your foot or rolling a piano over your toe, because splints, slings, and casts, which are necessary for healing bones, do limit your body's mobility and ability to practice. The final letter of our music acronym, B. Blood cells are actually made in the soft parts of our bones. Blood is our life force. It's made up of four main components: plasma, a liquid that transports nutrients, proteins, and hormones through the body and makes up about 55% of our bloodstream. Red blood cells are the second largest component to our blood, although they tend to get the most cred due to their color. Their job is to supply our body with oxygen and remove carbon dioxide. White blood cells are part of our body's immune system, which means they find and fight viruses and bacteria. Lastly, platelets, which make up less than 1% of our blood, form clots to stop bleeding and repair cuts and wounds. While you may not think of blood as having any sort of significant component in your music practice other than an inconvenient cut on your finger, it's actually what supplies our muscles with oxygen and allows us to move. And that's because everything is connected. The bones create the blood, and they protect the nerves, and the tendons and the ligaments hold the bones to the bones and the bones to the muscles, and the blood supplies the muscles with oxygen as well as the brain so that it can communicate via the nerves, so that the muscles know how to move the bones, so that it just continues like some never-ending circle of fifths. So we'll be exploring these principles and these biological concepts and these injuries in greater depth in every video from here on. Because just like you can't get very far in your music practice without learning your A, B, C's and your do, re, mi's, you're not going to get very far at an injury-free career without learning about your bodies. If you break an instrument, go buy a new one. But if you break you, you're kind of in trouble. And it's completely unfair that athletes get to learn about rest and recovery and stretching and warming up, and musicians get to learn about scales. So it's time for us to reclaim our education and have the best shot that we can at an injury-free career, less pain, and more music. I really hope you'll join me.